We did this example of find the number that is power of 3 and just over 200. So find number, and we are not finding power, we are finding the number itself, which is a power of 3 and just over 200. So we started with, so here's manually, I'm going to show what to do. You start with the number 3 as your number, and it is not over 200. So you multiply by another 3 to get 3 squared. You need to generate all the powers of 3 squared, and that's not over 200. So multiply that number by another 3, then it's 3 cubed, that's not over 200. So keep doing that repeatedly. So here's how the program goes. Int n equal to 3, and then while we need to repeatedly multiply this by 3. So while n is less than 200 or less than or equal to 200, it doesn't matter. It will never become equal to 200. So it doesn't matter whether it's less or less than or equal. What we need to do is multiply n by another 3 and put it back in n equal to n times 3. So that way n was initially 3 and it will become n 3 squared, 3 cubed, and so on. Okay, and then with this loop, only when n become over 200, it'll terminate. So when the loop ends, I need to print my number. So you can see that 3 squared is 9, and that's not over 200. And 3 cubed is 27, that's not over 200. So you'll go ahead and multiply by another 3. That'll be 3 to the 4th, that's 81. And that's not over 200. And it'll multiply by another 3. 3 to the 5 is 243. And now it is over 200. So that's when it will end. When it ends, the number is 243. So that 243 is what I'm printing by saying cout n. I'm printing after the loop. So when the loop ends, n has the answer. Now, suppose that the problem says, instead of printing the number just over 200, we want to find the number that is just under 300, under 200, that is. So let me reword the question. Find the number, which is a power of 3, and just under 200. In other words, it should be the largest power of 3, but under 200. We already have the answer on the screen. Which number is that? Anybody?
3.
The number
81.
Right, 81. It's not the power we're talking about. It's the number itself. The 243 is the one that went just over 200, and it's a power of 3. But 81 is the number that is just under 200, and it's a power of 3, right? 3 to the 4 is 81, 3 to the 5 is 243. So the largest power of 3 that would be under 200 is 81. All right, everybody understand that? So therefore, if I need to print that number, 81, instead of 243, how do I get that? Anybody?
Can you just change the signs?
Change what signs?
The greater and equal to.
Oh, okay.
Can you flip it? Can you just flip it?
All right, let me do that and then explain. You're saying let's change the less than or equal to greater than. Is that what you said, right?
Yes.
Let's write that and think about it. See, initially, what is the value of n? 3, isn't it?
3, yes.
Is 3 greater than 200?
No.
So the loop condition is false. So loop never starts. Okay.
Okay.
Oh,
Don't we have to change the whole equation then to like n is less than 100?
less than 100.
Yes.
Um, okay, even if I put less than 100, then it will be loop will terminate when it goes over 100, which is 243, right? So no, that's not the answer. You understand what I'm saying, right? The 3 to the 4 is 81, and 3 to the 5 is 243. So even if it is, if you're asking for the number that's over 100, that's 243. No, it's very, the solution is very simple. We just have to, we know that when the loop ends, it is over 200, right? We know that it's over 200. So all we have to do is take a step back from 243 to 81 when we print. In other words, just divide this by and print. That's 81, isn't it?
Yeah.
Right. So that,
Okay, got it.
yeah. So you need to take a step back. That's all it is. All right. So that finishes that. Let's go to section 4.4. Now 4.3, I'm skipping because there's nothing important there. It tells you about algorithms. Algorithm means, I can just state what it is, and that's all you need to know. An algorithm means writing the plan of the program in English without having to worry about language. So when you're doing a large computer project, it is a good idea to begin with planning. You write down step by step in English exactly how you would proceed to achieve the task. And then you translate that to a program. So then you can worry about the details. But first, writing out the plan of the program will be a good idea. And that's called algorithms. So when you, after you finish 271, 272, you will be taking another course called computer science majors. You'll be taking another course called algorithms. In that course, they teach you just algorithm for doing different things. And because you don't need to focus on writing the program, the idea of how to do something is what is important. You know, that's why that course is all about algorithms and without worrying about writing programs. So that's what algorithm means. So as we proceed, you know, in some examples, I'll show you what algorithm would be for that example. Let's begin our counting technique. Counting technique means sometimes we need to count how many times our loop is executing in order to answer certain question. I'm going to go into that. One student just came in, hold on. Okay, so sometimes to answer certain question or to determine certain answers, we need to count how many times the loop is going. So from the beginning to the end, how many times the loop was executed. That to count that, all you have to do is create a variable called count or something like that. It will be an integer and start it at 0. So you had to start it at 0 before the loop begins. And then inside the loop, just write count equal to count plus 1. So every time the loop is executed, the count will go up by 1. And that'll count how many times the loop is executed. So I'm going to use my next example to illustrate this, when you need to count and how to count. So here's the example. Suppose that, remember we did this problem, we just went over that same problem, 3 raised to 3, what number is a power of 3 and just over 200? That question we answered, it's still on the board. The answer was 243. Instead of asking what number is over 200 and power of 3, if I ask you what power of 3 is just over 200, now I need the power, the exponent, which, what is the answer to that? Still the numbers are on the board. So what is the largest power of 3 that is just over 200? What power?
6.
4.
No, 3 to the 4 is 81.
5.
Oh, sorry. It's over 200. Yeah.
200 is
5, right?
5. So now we want the power, not the number itself. I mean, in this simple question, we can even answer that manually, but we're talking about similar question with large numbers, then you need computer program to do it. So how do we do it? How do we keep track of, how do we determine the power instead of the number itself? I'm going to go to the board and modify the problem. We're going to, I'm going to erase some of the lines here. And what we need to do is, yeah, let me erase the loop also. What we need to do is introduce a counter. And in this case, my counter is going to be keeping track of the power. And therefore, I'm going to call it pow. So introduce pow, which is counter actually, and hold the power of the 3 that we are dealing with right now. Right now, n is 3, which is 3 to the 1, so the power is 1. So I'm keeping track of the power in this variable. Right now, it's 1. And then same loop while n is less than or equal to 200. Now I need brackets because I'm writing more than one statement in the loop. N equal to n times 3. N times 3. And now I also need to increment the power by 1 each time the loop is executed. So pow equal to pow plus 1. And close the loop. Now you can see that when n is 3, the power is 1. n becomes 9 when you multiply by 3 here, and power becomes 2. So it keeps track of the power. Then third time through the loop, n becomes 27 and power becomes 3. And next time, n becomes 81, power becomes 4. So power is keeping track of the power. So when the loop ends, what do I need to print?
Just the power, right?
Just the power. And that'll be the answer. 3 raised to what power is over 200 has been answered now. The number 5 will be printed by this. Now again, if I want to, if the question changes to 3 raised to what power is just under 200, what do I print?
Four.
Yeah, answer is 4, but this program should change to what in order to get that answer?
Divide by 3.
Divide what by 3?
No, when you see out the POW, it's a POW minus 1.
You just have to go down 1. We know that our power, when this power, whatever the power has right now, is the power to go over 200. So I had to go 1 less to be under under 200. So power minus 1 is my answer to print. So that's the difference. All right, moving on to the next question. We need to, yeah, if you need to write an algorithm for this problem to determine this answer, well, how would you write that algorithm? That's what I'm explaining here. You would write it this way: set num to 3 and count to 1, and then multiply num by 3 and increase count by 1, test num against 200. If it is less than or equal to, then repeat step 2. So this word repeat step 2 will become loop. So when you write it as an algorithm, you just mention exactly where the repetition should go. And if num is over 200, write the value of the count. So when the num is over 200, the loop should terminate, and you need to write the count. So that's how you write down the algorithm, the plan of the program. But in the future, I will not mention anything about algorithm, because this is all you need to know, what algorithm means. All right, so that's the program. I just wrote it on the board. So let's go to more examples. Example 2, write a program that obtains positive integer number from the user and determines how many of the positive integers larger than 1 and smaller than that number that can divide it evenly. The dividers, or these are called proper devices. That's what we are trying to find. A proper device would be a number that is not equal to the given number and not equal to 1, and it divides the number. See, 1 divides every number, and a number divides itself, and those two are considered to be not proper devices. So proper devices are numbers other than 1 and itself that will divide it evenly. So this example is to figure out what numbers will divide a given number evenly. So we're gonna write down all the devices. No, actually, we're going to count how many devices. Even if you need to write down the devices, we can do that. And in this problem, we're going to count how many devices are there. So to find all the devices, what you need to do is you need to start a variable called test num, or whatever name you want to use. And that should begin at 2. 2 is the lowest divisor. 1 is not considered to be proper devices, so 2 is the lowest one. So you test that 2 first. If 2 is not dividing it, then increase it to 3 and test that. And then if that doesn't divide, increase it to 4. Keep going all the way to 1 less than the given number. So let me use the board to explain using an example first. 243. Let's take the number 486. And if I want to find all the devices, or count how many devices are there, even if same number repeatedly divides it, we have to count it. So 486, I want to find how many devices are there. Then I should start with 2. So test number is going to start at 2 and test to see if it divides. How do I test to see if it divides? I just do n modulus test. And if it is equal to 0, then it divides the number. And if that happens, then I need to increment the counter. Basically, I'm writing the plan of the program right now. So increase counter. So if this is true, increase counter. And if that is not true, the counter should not go up. And then you increase the n. N should increase somewhere. And then you go back to the top and retest this for the new n. So that means the loop, this has to be loop. After incrementing n, you have to go back to checking this condition, whether to see if the new number divides it. So 2 divides 486, so the counter will go up by 1. And after that, you test 3, and 3 divides it, so the counter goes to 2. And then you do test the 4 and keep going, and all those numbers should be counted. All right, so how do we write the program? So the number is going to be coming from the user. So let's clear the screen instead of looking at the program, I'm going to just explain on the board how to write it. All right, so we need the number to come from the user. So let's begin with the main and declare int n is where the number is going to be stored. And count, I'm going to declare it as CNT. I don't like long names, and so if you just write CNT, it's understandable as counter, and set it to 0 to begin with. It must have a beginning value because later you're going to say count equal to count plus 1. So you're saying to the current value of count, add 1. So there must be a current value, otherwise it won't work. Okay, so the test number, I'll declare that as test. Test number will be initially 2. I'm going to use while loop, so I'm going to put 2 in it. If you're going to use for loop, then you don't have to have the starting value here. You can put the starting value within the for loop. So test is 2 right now, and my loop, I need a loop right now to the loop control is not going to be test number device n or not. See, if I write while n modulus test equal to 0, is that going to be a control condition for the loop? Let me explain why that's not going to work. Let's say 2 doesn't divide n. If 2 doesn't divide n, this loop ends, right? It doesn't check 3. So if 2 doesn't divide n, then we should go on to 3 and then go on to 4 and all that. So if this condition, if you use this condition, then if 2 doesn't divide, then this condition is false, loop doesn't even get started. So that's not the right condition. By the way, I forgot to write the statements to get the data from the user. So let me erase this. First, I have to get the data from the user. All right, so let's write the cout statement. Enter the number, cin n, and then the loop begins. So while something is true, we'll come back to it to figure out the condition. Clearly, the condition is not testing 2. Inside the loop, I need to test to see if 2 divides the n or not. So that would be an if statement, clearly. If n modulus test equal to 0, then what do I need to do? So this means test number, the current test number, which is 2, is a divisor of n. What do we need to do?
You need to increment the counter.
So count equal to count plus 1. So if the test number is a divisor, increment the counter. Now, that's the only statement I need inside the if. I don't want to put test equal to test plus 1 inside the if, because whether this condition is true or not, the test number should go up. So therefore, test number going up is outside the if. Test equal to test plus 1. And so I'm testing right now 2. 2 is the initial test number. I test that here. And if it is a divisor, counter goes up. If it is not a divisor, counter doesn't go up. Still, test goes up. You do have to do that. So with the new test, I close the loop so that it'll go back to the top of the loop. And as long as the condition remains true, it'll test the new test number. And if new test number is a divisor, counter goes up. Otherwise, counter doesn't go up, but it'll keep going. So what should be the loop control then? Anybody?
while test is less than n.
Test is less than n, right? Test should, when test hits n, we're done. We don't want to go beyond that. Test less than n. So test number should go up to 1 less than n. So while test less than n, keep repeating, and that will count. So when the loop ends, I just need to print the counter. See out count. So this program finds the count of all the devices of the given number. All right. So now let's proceed to look at the program. I just went over on the board, so I don't need to explain that again. And that's the explanation. Yeah, let me go through this explanation. Let's say num was 32. User entered 32. Then test number is compared against num. Test number is right now 2, and 2 is less than 32. So therefore, we are testing test number to see if it is a divisor. And it is a divisor, so counter goes up. Counter goes up by 1. And then the test number becomes 3. With the test number equal to 3, we go back to the top, and 3 less than num is true. So therefore, 3 is tested right now. Num modulus 3, is it 0? It is not. So counter doesn't go up, but test number goes up to 4. And then we're testing 4 here. We're checking to see where the 4 less than num is true. It is true. So now we are testing the 4 to see if it is divisor. And it is. So counter goes up by 1 again. And that's how it goes. And so it will count the devices. Now let me ask you a question. A prime number. So let's go to the board. What is a prime number? A prime number is a number that doesn't have any proper divisor. For example, 11. Number 11 doesn't have any divisor other than itself and 1. So it doesn't have proper divisor. Number 13 is a prime also. It has no divisors. So, so these small numbers, we can tell which numbers are primes when it comes to smaller numbers. So suppose that a very large number is given to you and you want to write a program to determine whether that number is a prime or not. Okay, then this program can be extended to do that. So the number is entered by the user and we got it in n. We stored it in n. And then we can do the same loop to count how many devices are there. Now we are not printing the count, so we don't need to print the count anymore. But by using the count, we can figure out whether the number n has is a prime or not. So can anybody see what to do? How to answer that question using this program? Instead of the cout, I'm going to write some statements that will determine whether n is a prime or not. Anybody?
If the counter remains at 0, then the answer is yes, it's a prime.
Right. If the counter never changed from 0. Originally it was 0, and if the number n doesn't have any divisor, the counter would not have increased at all. So it would remain at 0. So you can say if counter is 0, then cout number is prime. Sorry about my pencil, it doesn't always work right. Else, if count is not 0, if it is anything other than 0, that means a divisor was found. So in that case, I can cout not prime. And that'll be it. Okay, so this will be a program to determine whether a number given by the user is a prime or not. But this method is not efficient method. An efficient method would be, now in your algorithm class, that's what you will be learning more about, comparing different algorithms and determining which is best, which is the most efficient. Most efficient means it gives minimum work to the computer and achieves the task with lowest amount of work. And such a program will run faster, because the computer is doing minimum work. So that's what we call efficiency. This is very inefficient method to determine whether a number is prime or not, because we are finding all the devices and counting them. That is unnecessary. If you find one divisor for a number, you can immediately conclude that it is not prime. Why bother to find the other devices? That's what bad about this idea, this method. We are finding all the devices, even though we don't need to. So how do we then write a better program to determine whether a number is a prime or not? So I'm going to clear this and explain the other way, better way. So in the new method I'm going to use, as soon as we determine the number that has a divisor, as soon as we find the divisor, we immediately stop the loop. We don't need to test for any other divisor. And to do that, it'll be best, it'll work best if I use what is called a flag variable. A flag variable will flag something. So in this case, it's going to flag that the number is prime when number is not prime. Whenever a divisor is found, the flag is going to be changed to indicate that the number is not prime. And as soon as that flag changes, our loop should terminate. That's called a flag variable. And so this is the best time to introduce that and have you understand that idea. So I'm going to declare the integer variable for storing the number. And also I need the test numbers. I do need to test for devices. So therefore, test number should start at 2. And this time I don't need a counter because I'm not going to be counting devices. Instead, I'm going to use the flag variable is prime. I'm going to call it is prime. Is prime is I'm going to set it to 1. This is my flag, and if this flag holds a 1, that would mean the number is prime. So I'm going to begin with the assumption that the number is a prime. That's what I'm doing, and then I'll test all the devices, test for devices, and if I find a divisor, I know it's not a prime, so immediately I'll change my flag. Test number starts at 2, and I need to ask the user to enter a number. All right, let me get the pencil. All right, so cout, enter number, and cin n. And then the same testing that we did before, I need to do. So while test less than n, I do need to test all the numbers up to 1 less than n. So I do need this condition, but I'm not closing this parentheses yet for a reason. I'll come back and explain that. While test less than n, I need to test. So if n modulus test is equal to 0, if n modulus test equal to 0, what do I need to do?
Break.
No. By the way, no break can be used in any program except for switch. Switch is the only place where you can use break, and using break in any other structure is considered to be bad practice. Do not use that; you will lose credit. No, we don't need to break. I just explained a few minutes ago. We will start with the flag variable is prime holding a 1, and then anytime we find divisor, we'll change this prime to 0 to indicate that the number is not prime. Okay, so if test number divides n, that means we found a divisor, right? So what do I need to do?
You can set it equal to 0, right?
Set what? What equal to 0?
It is prime.
Is prime, yes. Is prime equal to 0? You change this prime to 0. And okay, so I still need to increment the n, right? In case this, only if n modulus test is 0, its prime will change to 0. But that may not be true. The current test number 2 may not be a divisor. So if it is not a divisor, then test number should go up and loop should continue to test the new numbers. So I need brackets. I have more than one statement now. So as soon as test is incremented to 1, I loop it back so that it'll go to the top and test less than n is compared. And if test less than n is true, the new test number is tested. And if new test number is 0, new test number is a divisor, then its prime will change to 0. So I keep repeating, and so its prime may change to 0 or may not change to 0. So that'll tell us whether if its prime is 0 when this loop ends, that'll tell us that the number is prime. But one more thing we need to do before we go to that conclusion. One more thing we need to do in the loop. See, I said we need to write the loop so that it will not keep going when one divisor has been found, right? If we have found one divisor, the loop should terminate. And if I leave the loop the way it is, it'll keep going, testing all the numbers, even after its prime turns to 0. Even after finding one divisor, which causes its prime to change to 0, the loop will still go on and check for the divisors by incrementing test to other numbers. But we don't want to do that. As soon as one divisor is found, we want to terminate the loop. So can somebody tell me how I do the modification here so that loop will terminate? A divisor is found.
You could say that if the divisor is found, test equals test plus n, which would automatically put it over the
Okay,
limit.
would be one way, but there is easier way than that. Then I have to write several statements here inside the loop, but there's an easier way. That is correct. It is one way. Is there another easier way? Anybody? Okay. Yeah, it's not easy to figure that out. So I'm going to explain that. The loop should continue as long as test is less than n, and as long as prime is still 1. Agree with that? Whenever its prime changes to 0, loop should terminate, right? Is
Got
that
it.
So we can say test less than n and is prime equal to 1. So 2 conditions to control the loop. Test number should be under n and is prime should be equal to 1. Only then loop should continue. And anytime a test number divides the n evenly, is prime changes to 0. And even though we are incrementing test number, the loop will terminate at that point because its prime has changed to 0. So whenever its prime is not 1, loop will terminate. So this is very efficient program because it doesn't test all the numbers If it finds one test number, its prime will change to 0 and loop terminates. Okay, now can you tell me what to do after the loop ends? We need to write the conclusion as to whether the number entered by the user is a prime or not, right? So when the loop ends, how do we know whether n is a prime or not? The variable is prime. This flag variable will tell us that, tell us whether n is a prime or not, right? How do I write that? Anybody? Okay, when the loop ends, I need to look at is prime. If is prime change to 0, you can either say equal to 0 or equal to 1. Either way will work. If is prime change to 0, that means the number had a divisor, so therefore it's not prime. So see out, not prime. Else, that means its prime didn't become 0. In other words, its prime was originally 1, and if no divisor was ever found, its prime will remain 1, and the loop will terminate only when the test number becomes equal to n. So its prime never changed to 1, never changed to 0, but the loop still terminates when the test number becomes equal to n. So now we can say if its prime changed to 0, then that means the number is not prime. Otherwise, it is prime. Okay, so this program is important to you because of this technique of using flag. So this, I may ask you to write this program in your homework, in your test, because this is a very critical program that you need to know how to write. All right, so let's proceed. I already explained that. I already explained all of these. So let's go to the, that's the more efficient method for to determine whether the number is a prime or not. And that is, it's there in your book. So let's see, warm-up exercise. All right, it says, write a program that obtains an integer from the user and counts how many times the number 3 is a repeated factor. So this is also checking for divisor, but here you need to test to see how many times the same number 3 is a repeated divisor. You know, if it is a factor many times, then it will, the number will be divisible by 3 many times. For example, let's take 54. Then the question is, how many times 3 is a divisor of this number? So I can see that 3 is a divisor. So if I divide by 3, I'm getting 18. So if I want to determine whether 3 is a divisor again, a second time, then I should test the 3 against 18, not against 54. You know, if we keep trying the 54, yeah, of course 3 is going to divide. But after dividing 54 by 3, you're eliminating one factor. After that, you want to see if 3 is another factor for this number 54. To do that, you had to try dividing 18 by 3. It does divide, and you get 66. So 3 is now already a factor twice. Is 3 another factor? To that, you had to divide the 6 by 3 to see that. It does divide, and you're getting it 2. So now we know 3 is a factor 3 times. So that count is what we need. 3 is a factor how many times for the given number? All right, see if you can write that. the same number 3 is a factor how many times repeated? That's our question. In this example, the answer is 3. 3 is repeated factor 3 times. And you can write it in your chat or show it on the screen. Anybody has an answer, please present it in the chat. Okay, I have a solution from Alexander. Okay, Alexander's solution is correct. Yeah, you need the body of the program. CN is not important. But yeah, your program is correct. And anybody else? Only one student presented a solution. Alexander, I'm going to write it slightly differently. So you should learn my technique also.
Sure.
Yeah, I'm waiting for others to write anything. Anybody else? No, nothing else. Okay, all right. No one else has another solution. So I'm going to take this solution from Alexander and explain that as one way.
I had a solution too.
Okay, great. Let's see. Yeah. While n greater than or equal to 3. Right, very good. Anissa has a right solution also. So let me see if I can paste that. All right, that didn't come out. That's what I'm going to try one more time. why it wouldn't. All right, let's just work differently. You can probably see this, but it's kind of small. Yeah, both of your solutions are similar. So I'll take just one of them. Can everybody see this, or should I try to enlarge? I don't think I can enlarge it. All right, anyway, let me just explain. You can probably see it, but it's very small. His loop control is while n greater than or equal to 3. So in other words, if n becomes smaller than 3, the loop should terminate. So he says while n is bigger than 3, he has an if statement that says if n modulus 3 is 0, then increment the counter and then divide n by 3. Of course, you had to divide by 3 to bring it down to the next number so that you can test the 3 on the new number. So in the if statement, he has if n modulus 3 equal to, by the way, it should be equal to 0. We need two equal signs, okay? So if it is equal to 0, then increment the counter. That'll count how many times 3 is repeatedly dividing, and then divide n by 3 to bring it down to the next number. So that'll be correct. That's one way to do it. And another way is, since we are counting how many times 3 divides the number, when 3 doesn't become a divisor, we can terminate the loop. So we can say, let's assume n has a number. I mean, if you're supposed to get the number from the user, then write the C out to get the number and C in n. So n has the number. And I introduce my counter up here, int n, and then count equal to 0. And then while okay, we're counting how many times 3 is a divisor of n. So as long as 3 divides n, I need to keep testing the same number 3. And if it doesn't divide anymore, we can stop. So therefore, I can say while n modulus 3 is equal to 0, as long as 3 is the divisor of n, increment counter. So n equal to count equal to count plus 1, and change the n to go down to the next. So n equal to n divided by 3. Divide the n by 3, like I did for 54. 54, 3 divides it, so therefore I divided it to get the next number. And so we have to keep doing it. So while n modulus 3 is equal to 0, increment the counter and divide n by 3 and loop it back so that it'll go back with the new n, new value of n, and testing the same 3 again. If it is a divisor again, then counter will go up and the n will go down.
Yeah, I just realized that the way I did it, you could get an infinite loop as well. So your way is definitely better because I'm not reducing n at all if it's not divisible by 3.
Oh, that's right, yes. I didn't notice that myself. The n has to be reduced, and if the 3 is not a divisor, you are not dividing n by 3, and that will become a problem, yes. So you have to terminate the loop in that case, and you're not doing it, yeah. So that's not perfectly right. It's almost right. It can be fixed, but let's not bother with that. You can see that this will terminate when n3 doesn't divide it anymore. So this loop doesn't get into infinite situation. All right, so let's move out of there. All right, so now we are
Professor, it's time, I think.
we are out of time. All right, so we are going to yeah, we're going to stop here, and I will assign the problems within the limit of what we have discussed. All right. So your assignment is due, there will be an assignment that's due Wednesday. And by the way, there is a project 4.4.1 that's going to be due 2 weeks from today. And also tentatively scheduling tests for 2 weeks from today. 2 weeks from today. Oh, I'm sorry. The assignment is due 1 week from today. Test is tentatively scheduled for 2 weeks from today. All right. And the practice test is already there. You may want to get started. The review for test 2. That's what it says. The title is review for test 2. You may want to start working on them. All right. So let's stop here. And so enjoy the rest of the day. I will see you Wednesday.
Wait, Professor, you said that the exam would be 2 weeks from today?
Yes.
Okay, got it. Thank you. Have a good one.
Thank you. Have a good day.
Take care.
Professor, what's the exam on the blackboard?
What's the exam on what topic?
On the blackboard, no, on the blackboard, we have a link. It says exam 1, spring 2021 to spring 21. What's one? In the folder test and quizzes in the blackboard,
Yeah.
what is it?
Oh, there is a test 2 on the blackboard?
I have no idea. It's test 1. It doesn't say whether it's test 1 or number or 2 without number. It just says computer science 271 exam 1.
Oh, that was
exam 1 or exam?
That was exam 1 you took.
Okay. Thank you so much.
Yeah, no problem.
Thank you. Bye.
Bye-bye.
When are your office hours?
Next office will be tomorrow, Tuesday at 5 p.m.
Tuesday at 5 p.m. And you sent out a link, or it's on Blackboard?
The link I send you for the new link I send you for the new office hour. And if you don't have that email, you can find it on the announcements.
And that's at 5 p.m., right?
5 p.m.
Professor, so the review, want to make sure, is on the course supplement review number 2, right?
Yeah.
Chapters 3 and 4.
Right, chapters 3 and 4.
And also, I think I mentioned this last time. I don't know if you could, you have the answer for the project, for the last project. I would like to learn the mistakes or anything like that.
Yeah, okay. You should have brought it up. All right, why don't you bring it up in the next class? I will present the solution. I will write up the solution.
Right, yeah.
Okay.
Okay, thank you.
You're welcome.